In this video, we're going to look at word problems that involve finding the max or min of a quadratic function. And what we really mean when we say that is finding the maximum or minimum y value of that quadratic function. In other words, we want to find the vertex of the parabola. A couple of instances where this comes up: if you imagine a projectile following a parabolic path, then if we're asked to find the highest height of that projectile, then that's the vertex, or the maximum y value. And we can think of this as a graph of time versus height. Also, if you have a business and you want to find the maximum possible revenue, let's imagine we have the number of widgets that you're making on the x-axis and the revenue on the y-axis, then it might be that your revenue follows a parabolic path as well, or if you make too few or too many, you're not maximizing the amount of money you take in. And again, we're trying to find the maximum revenue, and we want to find how many widgets we need to make for that. There's 4 different ways to find the maximum or minimum of a quadratic function. You can complete the square, which we've looked at in a previous video, and if you're having trouble with that, I'd urge you to go back and review that. You can factor and find the axis of symmetry. You can use this formula where the x value of the axis of symmetry, which is also the x value of the vertex, is equal to negative b over 2a, or you can graph the function using technology. And we'll look at using the first 3 in the examples that follow. The 4th you can plot on your graphing calculator and use the trace function. So here's the first example, and it's a common projectile question. In a baseball game, the height of a fly ball is given by this equation where h is the height in meters and t is the time in seconds, and we want to know how high does the ball get and how long does it take to get there. Looking at this equation, we can already start to sketch a quick height versus time graph, because we know that the y-intercept, or the h-intercept in this case, is going to be 1. If we plug time is equal to 0 in here, these will disappear, and we know that at time 0, the ball is at height 1 meter. And we know that it's a parabola that opens downwards because of that -5, so it's going to look something like that. And what we're asking is, what's that vertex? How long does it take along this axis to get to this point? And on this axis, how high is that point? So let's do this one by completing the square. H of t is equal to -5t squared plus 20t plus 1. We factor out the -5. And then we look for the number that is half of -4, that's -2. I'm going to write it there, square it, and put it back, and then subtract it back off. So we get -4t, -2 squared is plus 4, then we have to subtract that back off, -4, and we leave the 1 outside. Then we're going to kick that -4 out of the brackets. To do that, we have to multiply by -5, so it becomes plus 20, and then add the 1, and we get plus 21. Now we're left with a perfect square trinomial inside the brackets, and that factors to t minus 2 all squared. Our -2 has come back, plus 21. That means that this vertex is at the point 2, 21. Remember, we've moved the parabola right by 2 and up by 21, turned it upside down, and stretched it by a factor of 5 vertically. So the ball reaches a maximum height of 21 meters at t is equal to 2 seconds, which we did and found by completing the square. Another way that we could have done this is by using this formula: the x value of the axis, which remember is the same as the x value of the vertex, or the max or min, is equal to -b over 2a. And this formula is derived from the quadratic formula when everything under the square root sign becomes 0. In this problem, we're using t as our x value, so we would write t is equal to negative, and then b is 20, over 2, and a is -5. Make sure to include the negative and be careful of the signs. Now we get -20 over -10, which is equal to 2, and that gives us the x value of our axis and our vertex, so that's 2. To find the height as a function of time is equal to -5. We plug the 2 back in, 2 squared plus 20 times 2 plus 1. That's going to be equal to -5 times 4 is -20 plus 40 plus 1, and again we get 21. So that is our y value of our vertex. So this is another way of doing the same problem. Here's another very common type of problem, an area problem. What's the largest rectangular plot of land that we can enclose with 800 meters of rope if one side of the land is already bordered by a straight stretch of water, and what dimensions give us this area? So it's important to draw a picture here to make sure we understand what's going on. Here's our straight stretch of water, and we want to know if we take rope like this what's the largest area of land that we can enclose in a rectangular shape, and what are the dimensions of this land that give us that maximum area. So we're going to want to introduce some variables here. If this is the width and this is the length, let's let the width be W. We could use X if we wanted to, but I'm going to use W. Notice if that's W, then this is also W. Now this would be the length, and we could let this be L, but that would involve two variables now. What's going to be helpful is to think of how we can figure this out in terms of W. Now if we have 800 meters of rope to go all the way around these three sides, we've already used up 2W worth of rope, so whatever is left is going to be 800 minus 2W. As this width gets larger and this width gets larger, this is going to get smaller because we're subtracting 2W off. So we can write then the length is 800 minus 2W. Now if you're having trouble seeing that, you might want to at first introduce L as the variable for length, and then you would know that this W and this length, so 2W plus length, have to equal 800. Now if you want to rearrange this for L, you would get length is equal to 800 minus 2W. And that's an algebraic way of showing what we just did in words over here. Either way, we now have these dimensions, W this way, and 800 minus 2W that way. Now that we've done that, we can write area, which is equal to length times width for a rectangle, as 800 minus 2W times W. That's important because now there's only one variable on the right-hand side. And if we expand that and put it in the order of descending powers like we usually do, then we get area is equal to negative 2W squared plus 800W. If you think about area as our y value and W as our x value, this is the equation of a parabola that's opening downwards, so it's going to look something like that. And that's why we've rewritten everything in terms of W, because now we can see it as a parabola with x value W, y value A. And what the question is asking us for then is what's the maximum area? In other words, what's the maximum y value, and what's the W value, or the x value if you prefer, where that occurs? Again, it just means we're finding the vertex. We could do that by completing the square as we did in the previous example, but this time I'm going to show you a different method. That's finding the x-intercepts, or the w-intercepts here. In other words, if I find that x value and that x value, and I average them, I'm going to get the x value of the vertex, and then I can sub back in to find the y value. So remember that finding the x-intercepts, you need to factor. So I factor out negative 2w, which is a common factor, and I get this. And then I can see that if I set the left side equal to 0, then on the right side, w would have to be either 0 or 400. That if w is 0, this first part would become 0. If w is 400, the second part would be equal to 0. So this is 0, and this is 400. Averaging the two of them then gives me 200. 0 plus 400 divided by 2 is 200, and that's my axis of symmetry. W is equal to 200. That's also going to be the x value of my vertex here. Now, what I need to do is find the y value of the vertex, and I do that by subbing 200 back in for w. So when w is equal to 200, I get area is equal to negative 2 times 200 times 200 minus 400. So that's equal to negative 2 times 200 times negative 200, which when I multiply everything out is equal to 80,000. So that is the y value of my vertex. So this point is the point 200, 80,000. When width is 200, area is at a maximum and is 80,000 meters squared. The one thing we haven't found yet is what the length is. You can work it out quickly from here. If the width, is 200, this width is also 200, then this one is going to be 800 minus 2 times 200. Length is equal to 800 minus 2 times 200, which is equal to the 400 meters remaining. So we can see then that the maximum area is 800,000 meters squared, which occurs when the length is equal to 400 meters and width is 200 meters. So there are a couple of different examples of word problems involving finding the maximum or minimum of a quadratic and a few different ways of solving them.